49 is equal to 7 times 7. A square root has an index of 2. We don't usually put the index of 2. If you look at 2 and 3, notice that the index changed. If the index is not 2, we have to fill it in. So because it's a square root, we're looking for a pair of numbers. So the square root of 49 is 7 because it factors down to a pair of 7s. So the answer is 7. For question number 2, we're looking for not a pair but 3 numbers. So what number can I multiply 3 times to get 27? If you factor down 27, it factors down to 9 times 3. But of course, 9 factors down to 3 times 3. So 27 is equal to 3 times 3 times 3. So the cube root of 27 is 3. For question 3, we're looking for a number that multiplies 3 times to give you a negative 8. And that would be negative 2 times negative 2 times negative 2. So the cube root of negative 8 is equal to negative 2. One thing to keep in mind as we're simplifying radicals, if this index is odd and you have a negative number, that means that I'm looking for a negative answer. So I knew that it was a negative 2 and not a positive 2. On the contrast or contrary to that, if this was an even number, an even index, okay, like number 1 with a negative, we would have to leave the negative under the radical. So that's something to keep in mind as we simplify. Sorry, I thought I could swipe, but that did not work. Okay, so let's look at number 4. The index changed to 4. So that means that I'm looking for a group of 4. 4 of the same number that I can multiply to get 16. So we know 16 is 4 times 4. But 4 has a factor of 2. Okay, so there's actually 4 2's. So the fourth root of 16 is 2. Now, notice the difference between 4 and 5. We have a negative here. Okay, and because that index is even, I have to keep the negative underneath the radical. So the answer is the fourth root of negative 1. And I already know that the fourth root of 16 is 2, so I'm going to just put that 2 in the front. So it might be, so it's a 2, and then a little b4, and that negative 1 has to stay because you can't take the fourth root or an even index of a negative. When we're looking at variables, okay, it's a little bit different. So I'm actually going to write the letter X 8 times. Okay. So this means I'm looking for a group of 4. So if I have 8 X's, how many groups of 4 can I create? So that's 1 group, 2 groups. So that means that the fourth root of x to the power of 8 is x squared. I'm going to go ahead and introduce this rule for you to write down now. And it's called the even odd rule. And what that means is that if I start off with an even index and an even exponent and the result is odd, we have to include absolute value. Around that term. So for number 6, I had a 4, an 8, but I ended with a 2. So everything stayed even, so I don't need to put an absolute value around that x squared. But if, for example, I ended with an odd number like x to the power of 3, I would have to put an absolute value around. And I'm pretty sure we have an example like that coming up soon. Okay, so number 7 does not fall into the even, odd category because 5 is not even. So the easiest way to think of variables is if I have 10 people, how many groups of 5 could I make? With 10 people, I can make 2 groups of 5. So that means I have y squared. For number 8, I'm actually going to split it up. Each one is individual, so we're going to look at them individually. So the cube root of 125, and then we're going to take the cube root of x to the power of 6. And lastly, that is a 3 there. We're going to take the cube root of y to the power of 3. So when we start off with 125, that factors down to 25 times 5. And then 5 times 5 is 25. So that means we have a group of 3 5s. So the cube root of 125 is 5. For my x variable, I have 6. How many groups of 3 could I make with 6 people? I can make 2. So that means I have x squared. For the y variable, how many groups of 3 could I make with 3 people? Only 1 group, so I have y to the power of 1. For question 9, we have the 4th root of a to the power of 12. And we have the 4th root of b to the power of 8. So looking at the a, 4 is even, 12 is even. But if I have 12 people, I can make 3 groups of 4. So the 4th root of a to the power of 12 is a cubed. Okay, that would fall into the even, odd scenario because I started with an even index and an even exponent, but after I simplified it, it was odd. So this would have to have absolute values around it. But for the b, I have 8 b's and I need to make groups of 4. I can make 2 groups, but that does not need an absolute value because it ended with 2 and 2 is even. So you could write it this way. You could also flip it the other direction. Okay, just make sure that I can tell which variable is in absolute value. So it's definitely the a and not b. When looking at question 10, now we're back to an index of 2 because there is no number, so we know it's an index of 2. So we're going to take the square root of a to the power of 10, the square root of b, and the square root of c to the power of 9. So I have 10 apples, and I need to make groups of 2. I can make 5. So that would be a to the power of 5. For the b, the variable b, I only have 1. So I can't make a pair with one person. So that means that I have to leave that underneath the square root. For c, I have 9. So I can make 4 groups. So that's c to the 4th. But there will be 1 left over that has to go underneath the square root with the b. So that would be my final answer. question 11. Again, I like to split things apart so I can remember that I'm looking at each one individually. So I'm going to, it is a negative and the index is even. So we're going to take the negative out. So the first thing we need to do is figure out, well, what is the largest perfect cube that goes into 40? And when we think about perfect cubes, the smallest perfect cube would be 8, because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. But I know that it's an 8 that's in here because 8 goes into negative 40. So I'm going to split this down to the cube root of negative 8 and the cube root of 5. So the cube root of negative 8 is negative 2. And I'm just going to circle this because it has to stay. So I'm going to come back to that. So now let's look at our x's. I have 14 people, and I need to make groups of 3. So 3 divides into 14 4 times. So I can make 4 groups. Okay, but I would have some left over. I would have 2. So again, I have 4 that came out. So I'm actually going to write that down here with the negative 2. But those 2 that are left over, they have to stay. So I'm going to circle that again because we'll come back to that in a second. And lastly, we have the y. I have 10 people. I need to make groups of 3. So how many groups of 3 can I make with 10 people? I can make 3 groups. So that gives me y to the power of 3. I'm going to write that down here. But I have 1 y left over. So I'm going to circle that. Now the 3 things that I have circled, they all come together. So I'm going to make 1 radical. And underneath that radical, I have a 5. I have x squared. And I have y to the first. The even, odd principle would not apply here because we did not start with an even index. We started out with 3, and 3 is not even. When simplifying it as an exponent, these are radicals, okay? Because x to the power of 2/3, because it's a fraction, that could also be written as the cube root of x squared. But in this instant, we're just following our exponent laws, which tells us to, in this example, because it's multiplied, we would add. And we made this easy because it already has a common denominator. So the answer is simply x to the power of 7/3. And if you were to write that in radical form, it would be the cube root, because that's my index. Remember, the denominator is your index. The numerator is your exponent. So these two are exactly the same. So let's do the same thing in number 13. First, I'm going to add my numerator. So I have b to the power of 10/4 divided by b to the 1/4. And we're ready to subtract. And that gives us b to the 9/4. But if you were to write that in radical form, it would be the 4th root of b9. So let's do a couple of operations with our roots. When we're multiplying is quite simple. We multiply our numbers and multiply our roots as long as they have the same index. So for question 1, they're both square roots, so we can multiply it. So I'm going to start by taking 5 times -3. And then I'm going to multiply the square root of 8 times the square root of 3. 24 can be broken down, though, to 4 times 6, which is equal to 2. Okay, so what I really have here is negative 15 times 2 root 6. And my final answer is negative 30 root 6. For addition, we will simplify first and then see if we have like terms. So the perfect square that is a factor of 18 is 9. So that breaks down to 9 and a 2. The square root of 9 is 3. Bring down your addition sign. So the perfect square in 8 is 4. So that gives us 2 times 2. So we have negative 3 root 2 plus 4 root 2. Only because they both have a 2. That means they're like terms, and we can go one extra step and add the coefficient. We're adding the numbers in front. So our final answer would just be 1 root 2. And of course, the 1 is optional. You can put it, but you don't have to. For question 3, we're going to multiply it out, and we're just going to make a box, just like we did for the imaginaries in Appendix 7. And we're going to fill in our squares, see if we have any like terms. So the square root of 5 times the square root of 5 is equal to the square root of 25. And the square root of 25 is 5. Okay, so we just have a 5 in that first square. Negative 2 times the square root of 5 is negative 2 root 5. You cannot multiply a number by a radical. That number would just go in front. So that means here we just have 3 root 5. And in that last square, we have a negative 6. It just so happens that we have like terms, so we can add. So we're going to add these two, the 5 and the negative 6. And then we're also going to add these because they're like terms. They both have a radical 5. So our final answer is negative 1 plus the square root of 5. In Appendix 7, we talked about how we could not have imaginaries in our denominator. There's another rule, sorry about that, and that is no radicals or rational exponents in the denominator. Okay, so we have to do something about it. The denominator is kind of picky. There's a lot of things that we can't put down there. Can't put imaginaries down there. We can't put radicals down there. So we have to get rid of it. So the first thing we're going to do is simplify that radical. So the square root of negative 8 is equal to 2 root 2. So in order to get rid of that root 2, we're just going to multiply top and bottom by root 2. And that's it. So we're left with 3 square root of 2 over 2 times the square root of 4, which we know is just 2. So our final answer is 3 root 2 over 4. And now we don't have a square root in our denominator. Notice that we cannot reduce, do not reduce, or don't try to reduce the square root of 2 and 4. You cannot touch a square root unless you're taking out a perfect square, but you cannot divide that square root of 2 by 4. It cannot be reduced. That is your final answer. For question 5, just like in the appendix 7, we're going to multiply by the conjugate, and that would be the root 2 plus 1 top and bottom. So I like to break this apart into numerator and denominator. So 5 times the square root of 2 plus 1 is 5 root 2 plus 5. Okay. And then in my denominator, I am going to multiply it out, and I'll go ahead and make our box here. Which is optional. I know a lot of you don't make boxes. I noticed in your homework. So the square root of 2 times the square root of 2 is equal to 2. These two squares are going to cancel because they're opposite. Okay, you can go ahead and multiply it out, but you'll see that they'll cancel. And in this last square, you'll have a negative 1. When you combine like terms, you're left with just a 1. So your final answer would be 5 root 2 plus 5 over 1, or just 5 root 2 plus 5. So that is the answer to number 5. This 3 is your index and 2 is your power. So this means we're taking the cube root of 8 squared. So that can also be written this way. So that exponent could be underneath the radical, or you could also put it on the outside and put parentheses, wrap parentheses around it. So because I know 8 is a perfect cube, I'm going to start with that. So the cube root of 8 is 2. And then if I take 2 squared, I get 4. Okay. Here, this means we're taking the 4th root of 16 to the power of 3. 16, the 4th root of 16 is 2. And then 2 to the power of 3 is 8. Then we're going to do just a few more. These don't have common denominators. Well, the 9 and 10 don't. But for the first one, I feel like we already did this one, but I can't quite recall. But we'll just do it again. But we're adding our exponents, and they already have a common denominator. So that's x to the power of 7/3. Or it could be the cube root of x to the power of 7. And remember that exponent could be, so I guess there's 3 different ways you could say that you could write that. For question number 9, we need common denominators. So I'm going to start off by just writing everything over 30, because I know 30 would be my lowest common denominator for 5, 3, and 2. So if I use the denominator of 30, that would mean this would be 6 over 30, because I'm multiplying that 5 top and bottom by 6, times x. I'm multiplying that one by 10, so that would be 20 over 30, and then that would be 15 over 30. I just think it's easier to just write it all as one denominator, and that way you don't have to worry about doing a common denominator twice. So we're going to begin by adding our numerator. So that gives us x, and then that's 26 over 30. And that's over x, 15 over 30. Okay, and then we still have our common denominator, so we can subtract. And our final answer will be x to the power of 11 over 30. And our last question for Appendix 10. We have 2, 3, and 6, so we'll use 12. So that's 6 over 12. So I'm multiplying 4/3 by 4. So that would be 16 over 12. And then this one would be 2 over 12. Okay. So I'm going to begin by adding 6 over 12 and 16 over 12. So that gives me x to the power of 22 over 12 over x to the power of 2 over 12. So we're left with x to the power of 20 over 12. And that can be reduced. So we can actually divide that by 4. So our final answer is x to the power of 5/3.